Let's do number 10. We look at number 10. It says Felicia wants to draw a triangle PQR such that the conditions shown are true. The area of triangle PQR is not 6 square units, and the cosine of angle P is 0.6. Use the grid to the right to draw one possible triangle PQR. Well, in order to draw this triangle, we need to know the measurements of the sides. We're going to draw a mini version of this triangle off to the side. Right. I know. A little bigger. I know.
Here's the triangle.
Angle P is not a right angle because it gave us the cosine of angle P. You never take the sine or cosine or tangent of a right angle. So I'm just going to say angle P is this one. Doesn't really matter which one you make your right angle. I'm just going to say Q and R. But we just know P is not our right angle. Okay? So I'm going to make that top angle P. Well, we need to figure out the measurements of these three sides so we can plot it on this grid. We need to know the distances. Okay, well, we're going to take this information to help us find it. When we find the cosine of an angle or sine of an angle, it doesn't normally equal a decimal. It equals a, when we set up that ratio, it is set up as a calculator. 0.6 math, enter, enter. You have a graphing calculator. And what fraction does it give you? And what do you get? 3/5. That's really the ratio of those sides is 3/5. So if we look at SOHCAHTOA, cosine is what over what? What's the ratio of cosine? What over what? What does the A stand for? Adjacent. So we know the adjacent side to angle P has a measurement of 3. What does the H stand for? Hypotenuse. We know the hypotenuse has a measurement of 5. Well, to figure out where those exactly are in our triangle, let's label our sides. Let's start at our angle, go across. We label that as our what? Opposite. Okay. Go to your 90, go across. That's our hypotenuse. And the guy left over is our adjacent. And this problem is taking like everything you've done in this unit and combining it into one problem.
We'll stop, Jeff.
Yep. Keep that in mind. A lot of stuff going on. That's okay. It's good to see these. So, again, we said our adjacent side was 3, so we're going to say that side is 3. We said the hypotenuse was 5, so we're going to say that side is 5. In order to graph this, we need to find this bottom side. Well, how do you find the missing side of a right triangle? What do we use?
Yep.
Missing side of a right triangle. One side's missing. And we have the other two. What do we use? This is the first thing we did this year. Okay? Yeah, we could use a squared plus b squared equals c squared. Right? So we did some tricks. Now we're moving on to Pythagorean theorem. We'll label your sides. What did we say always had to be C? Hypotenuse. And the A and B don't really matter. I'm going to say this is A. I'm going to say that's B. So plug it in. We have 3 squared plus x squared equals 5 squared. And then you can go ahead and solve. So we saw 3 squared is what? 9 plus x squared. 5 squared is 25. Then you can go ahead and get x by itself. How are we going to do that? 25 minus 9 is what? 16. What do you have to do to both sides? So x is equal to what? So we found that this bottom side has a measurement of 4. So we found the measurement of all three sides of this triangle. Right? One side's 3, one side's 4, one side's 5. Here's the thing. What did it say about the area? Can't be what? 6. So let's just double check. We have it so the adjacent and the hypotenuse, adjacent of the hypotenuse is 3/5 or 0.6. We got that. We just need to see if it's the area of 6. So let's plug into the area of a triangle. What is the formula for the area of a triangle? Area equals. Anyone remember? You're good. Times part of it. It's on your reference sheet. You don't have to memorize it. Shane, what did you get? You got your reference sheet up? Yeah, 1/2 base times the height. Really close to 10 multiplied by 1. Alright, well, fill that in. We look at our triangle, what did we say the base was, or the bottom? Good, what's the height? 3. Well, 1/2 times 4 is 2, and 2 times 3 is 6. Well, our area is not allowed to equal 6, right? So there's a problem. But is there something we can do? What do you notice about all three sides of this triangle? It may say what? Makes what? Yeah, very good. It makes a Pythagorean triple. So what did we say we can do to the sides of a Pythagorean triple? Yeah, multiply by 2 or 3, multiply by the same number. Don't pick a really big number. So in third period, say 10. Those numbers wouldn't fit on the grid. So pick a small number. Draw a new triangle, just a reference. So this new side, we have P, Q, R. So we multiply this side by 2. Our new side would be what? Yeah. We multiply this bottom side by 2. Our new one would be 8. And then if we multiply our hypotenuse by 2, it would be 10. There we go. You want to just double check your work to make sure it applies. If we find the area, 1/2 our base times our height. 1/2 times 8 is 4, and 4 times 6 is 24. Good? Got that one down. And this doesn't change. Because 3/5, even if you multiply those by the same number, 6/10 still simplifies down to this. So that's not going to change. Sine and cosine doesn't change when you multiply the sides by the same number. So we're good. If that one works, we can go ahead and apply it. Doesn't really matter where you put it. I'm going to put mine right here. Put on the grid. We know this first one's Q, and you just count 8. 1, 2, 3, 4, 5, 6, 7, 8. And that's R. Then we're going to go 1, 2, 3, 4, 5, 6. That's P. And then you just connect that automatically 10 based off the other ones. And there you go. You could have recognized right away that if one side is 3 and the other side is 5, well, that's a Pythagorean triple. The other one has to be 4. And you could have saved yourself this work right here through the Pythagorean theorem. But it's great, because if you don't recognize it, you can still get the right answer, just a teensy bit more work. I have everything lumped into one problem. That's it.
One stop shop.
Yep. You're not going to have the one like this on your test, but it's just really good to see these problems all
Might
combined.
see this down the road.
Yeah. Might see it later.
When you see one like this, don't freak out. Let's see what we're doing here.
You know,
Everything is
questions. Okay? You look at the next one. This is what was on your skills check. For Linus is still in the place. Sine of what equals the cosine of 27? Well, if the sine of one angle is equal to the cosine of another, what do we know about those two angles? They equal what? 90. So, if they equal 90, what do we just have to do with 27? Subtract it from 90. 90 minus 27 is what? What is it? Yep. So we know that blank is 63 degrees. Or you could have set it up as made that an x, and you could x plus 27 equals 90, and then solve for x, and you still would have got 63. However your brain is. So 12 is really, really similar. So find the value of x if the sine of 3x plus 18 equals the cosine of 5x. Well, what did we just say? The sine of one angle equals the cosine of the other. What do those angles add to? And what? 90. You literally just take what's in the parentheses. 3x plus 18 plus 5x and set it equal to 90, and then you just solve. Well, combine your like terms. 3x plus 5x is?
All
Equals 90. Get 90 by itself. What do we need to do? 18. 90 minus 18 is? 72. And then lastly, what do we have to do with 3/8? Bye-bye. So x is equal to what?
Bless.
Questions over that. Again, when the sine of one thing equals the cosine of the other, those angles just add to 90. So you take whatever's inside the parentheses are written next to the sine and the cosine, you just add them and send them equal to 90. Questions over that? Okay, go ahead, flip it over.
Flip it over. Let's go on to the next one here. It's a good one. It's a blast for your pass. It will be frozen. Right here. You got these two guys. So we got a diagram below. AB is parallel to CD. Great. I'm going to mark that on there. And I also know it's true over this side too. Let's go ahead and find these. So all you got to do is basically figure out what kind of angle relationship these have. So remember, think back to those ones: alternate interior, alternate exterior, same side interior, corresponding angles, vertical angles, linear, all those good things. What kind, we're looking at A here, what sort of relationship do these two have? What is their pair, their special name that these two angles have with one another? Of those 6 that I said, what type are these? Eric, they are corresponding angles. They are sitting in the same corners. So if you think about the top one up here on AB, it's sitting in the upper left quadrant. Over here is the upper left quadrant, the same corners. What do we know about angles that are corresponding? What do we know about their measures? Their measures are equal. They're congruent. Again, in this section, we're reviewing this, that either two things are equal or two things are supplementary. Supplementary means what again? Adds to 180. So since these guys are congruent, we are going to set them congruent to one another. So here's what we do. 2x plus 30 is equal to x plus 80. And we're going to go ahead and solve. Let's try to move some things around. Who wants to move what first? What do you want to move? West, what do we got? Go subtract x, good. Smallest x, get rid of it. Minus x, he gone. 2 minus 1 gives me just x. Plus 30 is equal to 80. Wow, off the bat, baby bear problem. Next and last step is what? Yes, thank you. You were prepared for that. Minus 30 gone. X is equal to 80 minus 30. is B. Good. Are we done? Are we done? Yay or nay? Call, are we done? What? Why are we done? What are we looking for? Yeah, can we find X? Yeah, we're done. Doesn't go any further. I asked you like you were wrong, because it made it seem like we had to plug it back in to find the angle. Well, but we're done. I'll be confused. Just solve. You got it. Good job. All right, you were right. Next one. We got two more angles. Again, we know AB is CD or parallel to one another. We got that transversal to GH. Let's go. We've got to figure out what type of angle relationship these are. So that 3x plus 60 and that 60 degree. How are those bad boys related to one another? Think back to those angle relationships. What are they? Thank you, Lauren. Same side interior, very good. Interior is great. They're both inside those parallel lines, and they're actually on the same side. Since they're inside, the two options would have had same side interior or alternate interior, where that F would match up with that 3x and 60. But since they are the same side interior, we got some special other values. This is the only one that's different. Alexia, what is that special thing? They are equal to 180, otherwise known as their supplementary. Got a straight arm, go geometry view, sup. So supplementary equals 180. Let's add these up and set it equal to 180. Again, it looks like a difficult problem, but we always know once I set it like this, the next step will always be combining like terms. So let's combine like terms. Oh, the 60s. What am I going to do to those 60s? What do those turn into? Don't you dare say 0. Don't you say 0. Evan, what is it? You did say 0. Good for you. They're on the same side. Keep the same sign. So 3x plus 120 is equal to 180. Now we got it again. There's that there from. All right. You guys know what to do at this point, right? What do we do? Colby, thanks. Raise your hand. Subtract 120, 120. See you, 120. 3x is equal to 80. 180 minus 120. Shay, thanks for raising your hand. 60 is correct. Last step, we know, divide. So x gives me Carl, 20. X is 20. We done? See, now he's shaking right away. He does. He's prepared for this. All right, we are done there. Good. Question on those. Again, when in doubt, set two things equal. Because only one of them's equal to 180. All right, 1, 2, 3. Next question. This guy, number 14. So the diagram below, angle A is congruent to angle D, angle B is congruent to angle E. Determine why these are similar, then find X. Okay, cool, let's do it. Well, let's talk about these things are similar first. I'm going to go ahead. I know those angles are congruent. I'm going to go ahead and mark those angles on my picture. So I know that A is congruent to D. Possibly. Can't erase my hand. Okay? A. There we go. Is congruent to D. And I also know that B is congruent to E down there. Are these triangles similar? So think back to your similarity unit. Are they similar? Patty, head popped up. Are they similar? Why? Because they have congruent angles. What property tells me they are? It deals with those angles. You remember that one? There's three choices that you have with similar triangles. Side, side, side. Not happening here. Don't have all three sides. Side, angle, side. And this last one. What is it? Angle, angle similarity. Yes. These are congruent because what Patty said, there are two of them. So it's angle, angle similarity. So they are similar. So if they're similar, we know their sides are not equal, but they are similar, yes. So in this unit, when in doubt, what should we do? Proportion out. Good, I like it. So let's set up a proportion to solve for this. So someone give me that first ratio. Again, it's not hard, you'll probably be right. So what over what? Kat, thanks for raising your hand. She did raise her hand, microphone, just want you to know that. So, what is going to be my ratio? What over what? Just pick one of the sides. Go with it. X plus, X plus 2 over 3 is what she said. So I'm going to say here to here, x plus 2 over 3. Now, again, there are different ways to set this up. But how she started us off, we have to finish the other one in the same order. She went the big one over the small, or bottom over top, however you want to look at it. So this side over that side. So what's my other ratio going to be? We said that over that is going to be, yes, 18 over 12. Good. 18 over 12. Whoop, that's not a 12. Now let's draw a 3 again. That is wrong. All right. We know what we're going to do next, right? What's the next step with the solving proportions? Cross multiply. Very good. But before I do that, I'm going to do one little thing to help myself out. It's that thing with that binomial. What did I say to do if you have that binomial to help yourself out? Yes. Put parentheses so you stay consistent. All right, good. Now we'll cross multiply. I'll do this with highlighter because I was confusing people earlier, I guess. So I'm going to do that times that. All right. Well, I'm a nice guy. I'll do the first one for you. 12 times the quantity of x plus 2 is, well, 12 times the quantity of x plus 2 equals. This one needs some help over here. Those are the calculators. Start calculating away. What is 3 times 18? 3 times 18. Yes, sir. Jacob. What? 54 is what he said. And that is the correct answer. Nice. All right. Now, this is why Alyssa said to put this in parentheses, is because I want to keep myself organized. Because I know, you guys all know you're going to multiply 12 times that, but since I put parentheses, it means I have to put both in there. Now, what operation do I do next to help solve this? Yes, Leah. Distribute. I like it. Boop, boop. 12 times x is 12x. 2 times 12 gives me a 24. Equals that 5, 4 we had earlier. Guess what? Bear problem. All right, next step, we know what to do. Get rid of that 24. Get the thing furthest away. See you 24. You're out of there. Where's my little scroll down thing? There it is. Here you go. 12x equals 54 minus 24. 30. Uh-oh. Some of you are saying, what's going on here? I'm pretty good with mental math. I know we got some issues here. Aaron? 2.5. Yes, it doesn't specify what to leave it in. It doesn't say leave it in fraction form, whatever. If it doesn't say that, you can reduce it, simplify your fraction. It is simplify your fraction, excuse me. Leave it in decimal form. Speed. So x is 2.5. Questions with those? Proportions, you guys are all good with that unit. Let's look at the last one now, numero 15.
Take a look at 15. It's a little different. It says a square has sides that are each 90 feet long, which equations can be used to calculate d, the length of the diagonal of a square, in feet. So before I do anything, what do you think would be a really good idea? Yeah, draw it. Go ahead and draw a square. We have our square. What do we know about all the angles of a square? They're the same, and their measures are 90 degrees. All the same, they're all 90. What did it say about the sides of the square? They're all what? 90 as well. And then we have the diagonal. So I'm going to go ahead and draw that in. And what's that diagonal doing to those angles? Yeah, bisecting them, good. And so what's bisecting it? We're cutting it in. So what's half of 90? 45. So we know these angles are here. 45 degrees, 45 degrees. And it said that diagonal was D. That's what we're trying to find. Right? What do you notice here, though? What do you notice that we have? What kind of triangle is this? This is a 45, 45, 90, right triangle. Well, to find the diagonal, what do we literally just have to write? It's 90. the hypotenuse, which is the diagonal part, you just take whatever your leg is and you write radical 2 next to it. Well, there we go. We found our diagonal. Here's the thing. Any of those answers, 90 radical 2.
Ooh.
No, they're not. Okay? And it selects all that apply. So what do you think? Are we going to have only one answer or are you going to have multiple? Multiple. Whenever you see the select all that apply, that means you're going to have multiple answers. So now we can start ruling things out. Plug into your calculator. What is 90 radical 2 about?
Or people type it backwards.
What? 127. Give me a couple more. Give me 3 more decimal points. 279. So it's about somewhere around that is what your calculator is telling you, right? Right? Well, what we can do is just go through and plug all these values into our calculator, and whatever ones give us 127.279, those are going to be our answers. So go ahead and plug this guy into your calculator exactly how it's written. So you can do 1/2 or 0.5, doesn't really matter. 0.5 times 90 times 90. Plug that in your calculator.
Everyone should be plugging in a calculator so you can try this so you don't have to do it.
Then when you plugged A into your calculator, did it give you 127.279? Nope. So is that going to be our answer? Nope. Scratch that one out. Okay, go ahead and plug B into your calculator. So when you do that with your graphing calculator, you just hit second. And hit second x squared. And then 90 squared. You can either hit this button or hit the caret button. 90 squared plus 90 squared. Plug and then hit enter. You have one of our calculators. You're going to do 90 squared plus 90 squared. Enter. Green button x squared. And then you'll get your answer. Did that give us this decimal? Yeah. When you put it in your calculator, yep, gives you 127.279. So we know, hey, this is going to be one of our answers. It's equal. Do the same thing with C. Plug that in your calculator. Do second x squared to get the square root, and then it's 4 times 90 squared. Go ahead and plug that into your calculator. If you want working with R's, you have to do 4. Was that plus or times? So we do 4 or 90 squared times 4. Enter. Green button x squared. We're using our calculators. Does that give us 127.279? No, gives us 180. Can't be an answer. Wrap it out. So when your calculator's here, what you're going to do, you notice there's that variable there, it's D, right? What did we say D was? 9 D times radical 2. Well, that's what you're just going to plug in. You're going to take the cosine of 45 in your calculator, and then you're going to plug that in your calculator. You get the same thing, then you know, hey, that's my answer. If you don't get the same thing, then you know it's not. So you're going to do cosine. I need to check my mode. Yep. Which is in degrees. You do cosine of 45. Gives us that decimal. So then you're going to do cosine. This is really, when you're using graphing, you have to be very specific. You have to do, to get the fraction, which I think might be easier. To get that fraction in your calculator, you do green button, y equals, enter, and it gives you the fraction. You do 90, arrow down, 90, radical, arrow out, get the arrow over, goes out, hit enter. Oh! We get the same decimal? That's not right.
Don't need the cosine.
Oh yeah. Sorry. Don't plug in the cosine. Just plug in that fraction, I'm sorry. Do alpha y equals, just plug in the fractions, the other sign doesn't have cosine. Sorry, my fault. So then just plug in that fraction, you get the same decimal, so then you know, hey, that's an answer. You repeat the same thing with sine. So in your calculator, you're going to take the sine of 45. You get that? Hey, did we get that same thing on the other answer? Did we get 0.707? Did we got that on the last one? And when we plug that fraction in, 90 over 90 radical 2, we got that same decimal. So we know, hey, that's also going to be a correct answer. And then, again, please don't back up. You do the same thing with tangent. You do the tangent of 45. Well, that gives us what? We said when we plug that ratio in our calculator, that gives us 0.707. So we know, hey, that's not an answer as well. Hopefully all of you got that. Questions over that?